Hi, in this video, I will show you how to perform the two independent sample binomial proportion test using R. So the purpose of this test is to test if two population proportions are the same. And study design should be independent design. So the data should be random samples from two independent populations. The null hypothesis should be PA equal to PB. The alternative is PA not equal to PB, or you can have one-sided alternatives, PA less than PB or PA greater than PB. And there are two binomial tests. One is the exact test. So first, let me load the library. And then we need to input the data. So basically, there should be NA, that's the trials, and XA successes in group A. NB trials and XB success in group B. And then we do need to calculate proportions. Then we can perform the exact binomial test. The R function is binom.test. So the syntax is here. You can see we put XA and XB into one vector, and then NA and B into another vector. So this is the syntax for using the binomial test to compare the two proportions. And if we print out the result, you can see here, give you the number of successes and number of trials, and the p-value, and also give you the 95% confidence interval. Okay, the second test we can use, or we can try, is the normal approximation based test. We need to use the R function prop.test. So you can see the syntax is similar, but remember here we use the option correct equal to false. So we're not doing the continuity correction here. So if you fit them using this, run this prop test, it gives you a warning message. It says chi-square approximation may be incorrect. Okay. And if you print out the result anyway, it tells you the inputted data, the chi-squared, and the p-value, and the confidence interval. Okay. And this one also gives you the sample proportions. Okay. So you may wonder, what if we specify the correct equal to true, right? Well, let's try it out. You can see it still give you the same warning messages, tell you the chi-square approximation may be incorrect, and the output's a little bit different. So here, without the continuity correction, you got a p-value of 0.3. With the continuity correction, you get a p-value of 0.6. Okay, so The continuity correction is trying to improve the approximation of the normal distribution to the binomial distribution. But for this data set, probably the number of successes and the number of trials, they just happen to be in the way that the normal approximation is not very good. So that's why we get these warning messages that the chi-square approximation may be incorrect. So in this case, we should rely on the exact test result. Okay. All right. That's all for this video. Thanks.